Okay, everybody, how you doing? This is Kinesiology 231, and within 231, we're focusing a lot on Chapter 11. This is specific to the area of cardiovascular endurance. This will be an overview to some of the material and also to some of the concepts that are presented in this area in Chapter 11. There'll be a couple other presentations to further dig in and get a little more granular. So as a trainer, we have the ability to use submaximal cardiovascular tests to really understand a little bit more about our clients and understand what it is they can and can't do and understand their current situation in terms of fitness. We use this as a tool to help us paint a clearer picture. And with this picture, what we're really trying to do is come up with what is a client's VO2 max. And we know there's a relationship between submax testing, where we can evaluate VO2 max from those results. So as a testing protocol, it's great. We don't have to take a person to maximal effort. We can push them along. We can go ahead and take some measurements and be able to evaluate where they are currently. Now, many times it's very self-evident. The person's deconditioning never worked out before in their life. And so you know what the end result is, you know what the answer is. But for some of your clients, graded exercise testing and submaximal testing allows you to evaluate what the client is capable of at that moment. And it also provides a very demonstrative and measurable result that you're able to present to your client and state to them, look, you could work at this level previously and now you can work at this level. In actuality, we've, in some regards, through training, helped you raise your ability to work at a higher level. And those are very demonstrative when you talk with your people. The hard part is many times looking at even the equation VO2 max. People get a little wigged out by this, but this article that I found, the link is over here. You can just control click right to here and it'll take you right out. But it does a really good job of just showing what is self-evident with the equation. What is VO2 max? And you have this maximum rate volume of oxygen that your body is able to use during exercise, VO2 max. I love how this article is just really honed in on simplicity of what is VO2 max, and it really becomes self-evident what this term is in this sentence and vice versa. If we take this a step further in this article, same article, it also does a really good job of describing how it's a great predictor for athletic performance, but it also can help us measure and evaluate a level of cardiovascular fitness, cardiorespiratory fitness as noted here, for people who come in to work out with us. And it's a tool that, again, provides a benchmark, but it also is a tool that allows you to compare progress against that benchmark further down the road. So from our book, and this is back in chapter 2, if we look at really what we're after here, you have maximal oxygen uptake, VO2 max, right? It's the highest amount of oxygen that can be taken up, transported, et cetera, and used by the body. Okay, got it. But the other part of this equation, because there's an interrelatedness between all the systems in the body, and really this is an interconnected system. You have the heart, which is the pump squirting blood to either the lungs or to the body, and it's it's delivering oxygen to the muscles at terminal destination, and then it's bringing back waste product. Now, granted, there's more to it than that, but in terms of just a binary conversation here, I often describe this to my clients when I first sit down with them. Look, you have two main, if you want to think of like the subway lines here in Chicago, you have a red line and you have a blue line. And the red line is carrying oxygenated blood out, and we can further talk about hemoglobin and how you have the four tops and the iron and red, et cetera. But usually if you keep it nice and simple and you tell your clients, look, you have a red line out that's carrying blood and you have a blue line that brings blood back to the heart. You have oxygenated blood going out and deoxygenated blood coming back. Now, granted, it's not completely devoid of CO2 going out or devoid of oxygen coming back, but the ratio of the partial pressure on each side of that is different. So you're going to have a higher partial pressure of oxygen going out and a lower partial pressure of oxygen coming back. And the difference between those two is, quite frankly, at its simplest, is just the AVO2 diff. And what we're really trying to get across to our clients is when you start working out and we start talking about VO2 max, we have a very high correlation between how efficient your body can be in one functional area, but also another area. You start working out, it'll have a direct effect on VO2 max, but it will also have a direct effect on, in our terminology, Q, or the cardiac output, meaning how efficient your heart gets at ejecting blood with every contraction from the heart. The other side of this equation is when you go to terminal destination and you're offloading as much oxygen as possible and you're onloading as much CO2. You know, very much like on a subway, you got to make room as people hop off, people can hop on. What we're trying to do is become more efficient at the terminal destination for that blood, wherever it may be in the body. So you have this whole process that's interconnected, and you're trying to talk about how we're using graded exercise testing and submaximal testing to be able to evaluate where a person is. And when they start the process of working out, we know this is going to get better. We know over here, Q is going to get better, the ability to inject blood, the cardiac output is better. And we also know this is going to get better. So we have three different things that are positively correlated to one another, and they are all positively correlated to moving. And I took this a step further, and I took this from the book as well. You know, it's kind of the gold standard when we start talking about graded exercise testing and how to evaluate clients. And as I noted before, there's a relationship between max VO2 and graded exercise testing and even submaximal testing. And you'll usually have a cart next to the person. They'll have a mask on. We're doing open circuit spirometry. We're measuring a number of different variables. And we're doing so to evaluate the human body and how it responds to exercise that's placed on the system. Basically, it's a stressor placed on the system acutely, and we're just evaluating how the body responds. And as a result, you know, we know that clients will respond by increasing respiration, increasing heart rate. And there's an acute response that's actually an overcompensation, and we try to take the client into a steady state to be able to measure in a window of time to have an accurate result. Now, these guys are slightly different. You have VO2 max and VO2 peak. VO2 max is a little bit more about like your genetic potential. You can affect that through training, no doubt. VO2 peak is the highest, if you will, that a person will reach during an exercise bout. And it can be the highest VO2 that a person will have, say, over the course of a mesocycle, if you're recording that from week to week to week. And what happens is you have this kind of ascending chart that matches or tries to align with VO2 max. Now, elite level athletes, these two are probably very close to one another. Your newer people, it won't be so close. And we use this again as a relationship to show our clients, look, when you have a higher VO2 max, we know that there are decreased risks of many different comorbidities. And you know, that negative correlation is super helpful in being able to sell people on the concept of exercise. Now, there is, in our parlance, you know, we look at this and go, okay, it's widely accepted. There's plenty of data points. We know it correlates very well with physical conditioning, so that's also a great point. And then we have a higher VO2 max. We know, as I just stated, we have a number of different comorbidities that actually come down. So there's a negative correlation between those two. And we also know that resting VO2 max is typically estimated at about 3.5 milliliters per kilogram per minute of consumption. And man, if that's a slide that doesn't have a couple quiz questions on it, I don't know what does. All right, so with aerobic training, we know we can bump up VO2 max, which is great. And we know that we have a number of different things that kind of limit our ability to bump up VO2 max. But I will tell you, this 10 to 15% doesn't extrapolate out into a 10 to 15% performance gain absolute with your clients. It actually, there's a leverageability to this where your clients become better and more efficient at working and working harder. Great, so we can improve it through some workouts, fantastic. We know we have a couple of different things that kind of limit us in terms of our genetics. But we know that whether it's good nutrition, good recovery, or training, we can really make some progress in this area. And the quirky thing is, what you'll find is you'll have the greatest amount of improvement seen in deconditioned individuals, and that's on the front end. And when you look at that, I have to ask, well, if we go ahead and have a few questions again on another slide, here we are, let's take a moment. Why would a deconditioned individual show greater results, especially on the front end of a workout program? Can you even describe what cardiac output is, what Q is? How about AVO2 diff? Right? Can you go ahead and articulate what that is? Again, these are 3 great questions that you might find somewhere else in this class. And I would tell you, your deconditioned people have the greatest margin and they have the greatest opportunity to show results because they are the furthest away from their VO2 max. They're just starting out, and really they have no concept of how hard they can work at this point, and their bodies have to learn how to become more efficient in pumping blood and having greater cardiac output, which is Q, and then also greater ability for oxygen exchange at terminal destination. So you look at that and you go, okay, arteriovenous, arteries take blood away from the heart, venous brings blood back to the heart, greater oxygenation here, less oxygenation there. When you have a bigger difference, you know you've squirted off or offloaded more oxygen at terminal destination. If you want a little more insight to that concept and how, like, when exercise levels increase, you have a greater amount of oxygen in the system to start, and you have ratios that change as you start working out, I would click to this link right here. It's a really good video by another gentleman. So, you have these things that you have to be able to answer for your tests and questions in the class, but also you have some things for your clients. So when we look at this, when we go back to our chapter 11 material, there are some assumptions you got to make. The heart rate has to be at a steady state to evaluate. We have to have it in terms of the heart rate itself is measurable. So as you're working in the beginning of an exercise test, your heart rate is still escalating. It's not at a steady state yet. So you have a window of opportunity in there where you can take 2 measurements at a steady state, and that is your valid measurement. And we know true maximal heart rate will be the same for all clients at a given age. The relationship between heart rate and work rate must be a strong positive and linear relationship. We know that to be true in terms of our submaximal test. And with this, the efficiency, meaning how well VO2 is at a work rate, is the same for all clients. Okay, so how efficiently they are squirting blood, how efficiently they're offloading oxygen and onloading CO2 will be the same for all clients. You can make the argument that in some cases it might not be if you have pulmonary issues, but that's another conversation. These are assumptions you make for submaximal tests. This is in your book. So again, if there's another test question anywhere in here, boy, here's one right here. Steady state heart rate is defined as 2 consecutive heart rate measurements that are within 5 beats per minute of each other. You know you're at steady state at that point. So here he is, running on a treadmill. He's probably pretty deep into his graded exercise test. Depending upon the protocol, you might have a little more of an incline to that, but we'll let that go for right now. So when you use a graded exercise test, what's happening is you have a systematic and linear increase in workload. So as this gentleman's working, we're increasing the speed, we're increasing the incline, we're increasing the speed, we're increasing the incline. And we're forcing a stressor on his body to see how his body adapts. He's doing spirometry, so we're measuring how much oxygen he's actually sucking in versus how much he's blowing out. And that's helping us gather enough information to be able to come up and calculate his VO2 max. All right, guys. If you want a little more information on this topic, you can click right out to this article right here. It's a pretty beefy article, but it gives good insight regarding VO2 max and graded exercise testing. And to that end, guys, you got a couple more videos coming. Hope you enjoyed that one. Thanks.